All right, so as we mentioned before, there's two different ways of writing a quadratic equation. One is in standard form, which you see here on the top, and the other one is in vertex form. Vertex form is a little bit easier to graph it when you aren't using a calculator or something than the standard form is. So sometimes we want to change standard form into vertex form. One reason is because graphing would make graphing a little bit easier. Another reason is because actually it's really how we got the quadratic formula in the first place. The thing that we learned where x equals negative b plus or minus the square root of b squared, etc. Right? The reason why that formula even exists is because of this process of changing a standard form quadratic into a vertex form. I might show you guys how that works, maybe even offer that as an extra credit. But for now, just know that it is useful to be able to change a standard form into a vertex form. And that's what today's all about. Okay. So let's go ahead and jump in and see what we can do. So now, basically, like I said, our goal today is to change the standard form into vertex form. Something you'll notice is that comparing the standard form to the vertex form, notice they both have an A. So that's going to just stay there. But notice the B and C are gone. Instead, we have an H and a K. And that's because as we go through this process of transforming it, a bunch of weird stuff happens to the B and C, and they become completely different numbers. So you end up with a whole different thing. Notice also it has this little square situation, right? We have x minus h squared. So that's going to be a lot of our discussion today is going to be talking about how to create that out of this stuff. Up here is just x squared. Down here we need an x minus h squared. So a lot of our discussion is going to be about how to get there. All right, so before we begin the official process here, we need to learn some stuff here. We're going to start by talking about these things called perfect square trinomials. So what is a perfect square trinomial? Well, a trinomial is a polynomial that has three terms like this, and it's quadratic, so it has a second degree power there. You might notice it's a standard form quadratic. But here's what's interesting about it. When you factor this, which is something that maybe you guys don't remember how to do, but that's okay for now. We don't really actually need to know how to do that today. When you factor this, it factors into x minus 5 times x minus 5. You end up with two identical factors, so you can write it as a square. And that's why we call this a perfect square trinomial, because when you factor it, you end up with two identical binomial factors, so you can write it as a square. Now, why do we care about that? Well, once again, our goal is to change standard form into vertex form. And check this out, x minus h squared, that is a factored perfect square trinomial. So somehow in the process of the day, we're going to be changing what we have into a perfect square trinomial so that we can get this in there. Okay, so that's the goal for today. Now, how do we create a perfect square trinomial? Well, that's a process called completing the square. Completing the square is a process that we go through to change a trinomial into a perfect square trinomial, right? Now, before we show you how to do that, I'm going to back up to this slide here, and I want to show you something. When you factor this out, the number that's right here is related to these two numbers. Okay, so -5 and -5, you put those together, you get -10. In other words, if you take half of this middle number, that's what tells you goes here, right? And here. But also, if you multiply these two numbers together, that tells you what goes there. So, basically, a perfect square trinomial is a problem where if you take half of the middle number, which is -5, and then square it, you should get this number. And that's what a perfect square trinomial is. If it's not like that, then we're going to make it like that. Okay? So let's go ahead and take a look here. So in order for this to be a perfect square trinomial, The number that is here needs to be the square of half of this number. So let me show you how to work that out. So to create a perfect square trinomial, what you're going to do first is, first of all, you're going to take half of the 8. So what's half of 8? Well, half of 8 is 4. And then you're going to square it, which is 16. And that's a perfect square trinomial. Now, once again, you guys don't need to know how to factor this, but if you did factor it, it would be x plus 4 times x plus 4. In other words, x plus 4 squared. Now, why don't you guys need to know how to factor it? Because there's a shortcut for factoring, okay? But before we talk about factoring, let's just make sure you know how to complete the square. I would like you guys to see if you can pause the video here and fill in this blank with the appropriate number. Pause the video and see if you can fill in the blank with the appropriate number. The first thing that you should have done, you should have taken half of the 12, which is 6. And then you should be squaring that number, raising it to the second power. 6 squared is 36. So the number you should have put here is a 36. Okay? And that's what we call completing the square, because it creates a perfect square trinomial. Now, I want to do a little bit more work with you guys here on one of these. So I want to show you guys how to actually factor one. So now, as you guys saw, you don't need to write this, you can just watch, but on my problem here, this was x squared plus 8x plus 16. Well, we know since it's a perfect square trinomial because we made it one, we know that when we factor it, it's going to basically be x plus or minus something squared. It's always going to look like that. And the number that goes here is always going to be half of the middle number. So in factored form, it would just look like this. Okay, so now let's go back to your guys' problem here. On your guys' it was 36. So here's what I want you guys to do is I would like you guys to write the factored form of this expression by filling in this blank right here. Pause the video and see if you can do that. As you guys know, we said in the last slide, half of that is 6, and that's the number that goes here. Now the sign matters. Since this is a positive 12, we get a positive 6. If it was a minus 12, we would get a negative 6, okay? Now I want to give you guys one more problem to do from the beginning. I'm going to do one, and then I'm going to let you guys try one. Okay, so let's say that we had x squared minus 4x plus blank. And then that's going to be for me. So we're going to, first of all, we start by taking half of the 4, which is negative 2. And then we're going to square it, which is 4. So there's that. The next thing we're going to do is we're going to factor it. And when you factor it, you always take half of the middle number. So my final result there will be x minus 2 squared. So we completed the square, and then we factored it. And I want you guys to try that now. So I'm going to give you one. Complete the square, and then write it in factored form. Pause the video here, and when you're done, we'll put the answer up. All right, so half of 14, you guys should have gotten negative 7, and then you should have squared that and gotten 49. And now that's a perfect square trinomial. And when we factor it, we should get a binomial being squared. And the number that goes here next to the x is half of the 14, so it would be x minus 7 squared. Okay, and so that is completing the square and factor. All right, so that being said, now that we know how to complete the square, we're ready to actually do the problem that we came here to do today. So I want to back up a little bit, and I just want to review with you guys what our goal for today was. Our goal for today was to change something from standard form into vertex form. Now the first thing we're going to need to do is get that a out of the way. So pull it out. So it's going to be outside some parentheses. And then whatever's left after we take out the a is we're going to complete the square and create one of these perfect square trinomials in factored form. There's some other things we're going to do too, but that's kind of the basic idea there. And why do we want to do this sort of stuff? Why do we go through this process? A, it helps with graphing. B, it also helps us solve, and it tells us where the quadratic formula comes from, which I said I might show you guys a little later for an extra credit assignment. But for now, this is what we have to work with. So what our goal here is to change this into a, what is it? It's, matter of fact, I should have put the instructions in here. I'm going to put change to vertex form. So that is our goal for this problem. Change it into vertex form. Okay, so I'm going to label these really quick. This is the A, this is the B, and this is the C. Okay, now the first step that we want to do is we want to get rid of that C. So I'm going to put move C to the other side. This is a problem where you would probably want to be writing down these steps because there's quite a few steps. You'll want to be writing them down as we go. All right, so step one is to move the C to the other side. So let's go ahead and do that. I'm going to minus the 13 on this side, so it's no longer on the left. And whatever you do to one side, do to the other. So now our 13 is on the right side. All right. The next thing that we're going to do is we want to factor out the A. So this 2 in the front here, we don't want it there. We want to pull it out of what's left. We want to factor it out. So it's factor out the A. Okay, so what do I mean by that? Let's show you. All right, so I'm going to put 2 parentheses equals y minus 13. And in parentheses, I'm going to put what would be left if I divided both of these by that number 2. So if I divide the first term by 2, I'm left with x squared. And if I divide the second one by 2, I'm left with 6. So I've factored out the 2. I've divided out the 2, and so we're left with what we have there. Okay, now the next step, we are going to complete the square. So that means we need to add a new number inside the parentheses here so that we end up with a perfect square trinomial. So I'm going to leave a little space right here. And this is where we take half of the 6, and then we square it. And that's the number that's going to go right there. All right, so we've completed the square. Now, what we've just done, though, is mathematically illegal. What do I mean by that? Well, I just added a number here on the left side of my equation. And an equation is like a balance scale. These two sides are supposed to be equal. So if I create a new number over here, I just upset the balance. It's no longer equal. And so what we need to do in step 4 is we need to fix the balance. So you might be thinking, well, okay, we put a 9 on this side, so let's just put a 9 on this side and that'll balance it. Well, that's good thinking, but that's not quite enough. The reason is because you might notice that this 9 is in parentheses, and everything in these parentheses is being multiplied by 2. So actually, by putting a 9 in here, we actually put 2 times 9 on this side, which is 18. And that's what we need to add to the other side. So for the next step, here's how I like to show my work for this one. To fix the balance, what we're going to do is we're going to rewrite all this really quick. Oops, not equals. minus 13. And what we do is we are going to put, I'm going to show this. I'm going to put multiply. And then I'm going to do this, put add. It could be subtract. It just depends on the sign. But in this case, 2 times 4 is 8, so we're going to add 8 to this side over here. Okay? I'm sorry, 18. 2 times 9 is 18. Sorry about that. So 2 times 9 is multiply, and then add that number over here, that's 18. So that's what we need to add on the other side to fix the balance. All right, next step is we need to factor and simplify. Factor and simplify. What do I mean by that? Okay, well, this perfect square trinomial that we have right here, we're going to factor that using the little shortcut I shared with you guys earlier. It's always going to look like this, and then to find out what goes here, we just take half of that middle number right there. So what's going to go there is 3. That's the factoring. And what about the simplifying? Well, the simplifying is just putting the negative 13 and the 18 together. So if I put those together, I get y plus 5. Okay? And we're almost there. We're almost done. The last step is to take this 5, which I'm going to call the k value now, and move it to the other side. So the last step is to move k to the other side. Okay, so let's do that. So I'm going to put minus 5, minus 5. So now we have 2 parentheses x plus 3 squared minus 5 equals y. And now it's in vertex form. Here's my a, here's my h, and here's my k. So we've successfully changed it from standard form into vertex form. And now we could graph this. And there's other things we could do with it too, but we haven't gone over those yet, so I'll leave it at that. But we have now successfully changed it from standard form into vertex form, and here are the steps. So it's a 6-step process. Move the c to the other side, factor out the a, complete the square, fix the balance, factor and simplify, move k to the other side. Okay? Let's go ahead and do another one. So this time we're going to do a guided practice, and what that means is you guys can do each step one at a time, and hopefully you guys wrote down those steps. So what I want you guys to do here is I would like you guys to do step 1. Pause the video, and when you unpause it, you will see the first step done. And that's the end there of step 1. Just adding the 9 to the other side. Okay, go ahead and do step 2. Pause the video, and when you unpause it, you will see the solution. All right, so step 2 was to factor out the a, so I've done that. And you got to be careful here. You're dividing by a negative number, so when you do that, the 8 divided by negative 4 is going to leave you with a negative. Okay, now I'd like you guys to do step 3. Pause the video, and when you unpause it, you'll see the solution. Step 3 was to complete the square, so you should have taken half of negative 2, which is negative 1, and then you square it, or raise it to the second power, 1, and you add that number right here. So there's that. Go ahead and do step 4. Pause the video and check your solution. Step 4 is where you fix the balance. And you do that by multiplying the negative 4 times 1, which is negative 4, and you're going to add that to the other side. Now, if you add a negative 4, you're actually subtracting 4 on the other side. So notice I put a negative 4 on the right side now. All right, go ahead and do step 5. Pause the video and check your solution. And step 5 was to factor and simplify. So if you factor the perfect square trinomial there, it's always going to be parentheses x parentheses squared, and the number that goes next to x is the only thing that will ever change. That number will always be half of the middle number, so half of negative 2 here is negative 1. So that's why that's there. And then on the right side, we simplified by just doing 9 minus 4. And that's step 5. All right, so go ahead and at this time do the very last step, step 6. Pause the video and check your answer. All right, and so there we have the final answer. And now we're going to let you guys try to do one of these all on your own from beginning to end without me walking you through step by step. So try both of these and see how you guys do. Pause the video. When you unpause it, you'll see both of them completely worked out. Okay, and here are the final solutions at the very bottom. On the left side, we have this as the final answer. On the right, we have this as the final answer. You guys can check the steps there. It's just the 6 steps that I provided you guys with earlier. Pause the video if you need to look at them a little longer, because I'm going to delete those now. And that does it for our lesson today. So we will see you guys next time.